Okay guys, we're starting a new unit today. Unit 11 is about sequences and series. And so in this first section, 11-1, we're talking about sequences. First thing we come to is the definition. So you've got two types of sequences that we're going to be looking at. Okay, an infinite sequence is a function whose domain is the set of positive integers, and it includes an infinite number of terms in the sequence. All right, and if the domain of the function consists of the first n positive integers only, then it's considered a finite sequence. All right, so an example of a sequence would be 2, 4, 6, 8, 10, 12. All right, and if it continues on and never stops, then that would be an infinite sequence. All right, and if we say, okay, we're going to take the first 6 terms and then stop at 12, then that would be considered a finite sequence. All right, so a sequence is just some pattern that you use to get the next number in line. All right, and let's see here. Now, there's two types of formulas that we're going to look at that can give us the sequence. And so the first one is called the explicit formula, and that gives the nth term a sub n as a function of n. And the explicit formula allows you to quickly tell, like, what is the 10th term of the sequence by plugging in 10 for n, or the 15th term by plugging in 15 for n. All right, so most of you have had experience looking at explicit formulas. Now, you also have what's known as a recursive formula, right? A recursive formula. And a recursive formula allows you to get the next term in the sequence by defining it in terms of the previous term of the sequence, right? And we'll get to some examples of that. So an explicit formula, you can just put in whatever term number you want. Like if I want the 50th term, I can plug it right in for n and get it. But with the recursive formula, if I want the 50th term, I would have to plug it in over and over till I get up to 50. So that's kind of the difference between the two, and you'll see in the examples the difference. All right, so here's our first few examples. It says write the first 4 terms and the 15th term for each sequence. Now, take a look at the formula that they've been given to me. Okay, the first thing that you should be able to do is recognize whether this is the explicit formula or the recursive formula for this particular sequence. And by looking at this, remember, it's defined in terms of n, right? Which means it's the explicit formula. I could plug anything that I want here for n, and I can get that term. Like if I wanted the 100th term, I could plug in 100. 100 times 3, 300 minus 2, 298 would be the 100th term in this particular sequence. Okay, so you can tell very quickly whether you've got the explicit formula or the recursive formula. The recursive formula would be defined not in terms of n, but it would be defined in terms of a sub n minus 1, meaning the previous term, right? So the next term, the current term, would be in terms of the previous term and then plus, minus, or times something. So it would always have a sub n minus 1 in the formula for the recursive formula, and you always have an n in the formula for the explicit formula. That's how you can quickly tell the difference. All right, so back to the type of question that we have here we're trying to answer. The first 4 terms in the sequence. So that means I need a sub 1, I need a sub 2, I need a sub 3, I need a sub 4, and I need a sub 15. All right, so that's how you write out the term numbers, right? The subscript tells you what term number you're looking for. All right, so if I wanted the first term, right, then what do I need to plug in for n? Well, I need to plug in 1 because n is the term number. So what's 1 times 3 is 3 minus 2 is 1. So the first term is 1. Plug in 2, I'll get the second one. 3 times 2 is 6. 6 minus 2 is 4. 3 times 3 is 9. 9 minus 2 is 7. And you can kind of see the pattern now. 4 times 3 is 12. Minus 2 is 10. Let's go ahead and plug in 15. 15 times 3 is 45. Minus 2 is 43. All right? And so that's how you would use the explicit formula. Same thing here. I need the first 4 terms and the 15th term. So I want a sub 1. I want a sub 2. a sub 3. A sub 4, and A sub 15. All right. Okay, so with this one now, I'll need to plug in 1 for n, right? So what's negative 1 to the first power? Okay, negative 1 to the first power is negative 1. And so 3 minus 1 will make 2. All right, now I'm going to raise this up to the second power. Well, what's negative 1 times negative 1? I'd say that's positive 1, right? And then positive 1 plus 3 is 4. All right, third power. Negative 1 to the third power is negative 1. And then 3 minus 1 is back to 2. So you can kind of see the pattern now. Fourth power, negative 1 times itself 4 times is positive 1, plus 3 would be 4. And now that we kind of see the pattern, we can see what negative 1 to the 15th power is going to be. Well, if it's to an odd power, it's going to be 2. If it's to an even power, it's going to be 4. And so when we look at this one, this is an odd power, so it's going to be 2, right? So 2. All right. So odd power would be negative 1, so 3 minus 1 would be 2. All right. And so you can see there are different types of sequences. This one goes up by 3 every time, so the numbers get bigger and bigger. This one just bounces back and forth between 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4. So you can see there are different types of sequences. All right. Okay, here's the next example that we come to. Again, same directions. We want to write the first 4 terms and the 15th term of the sequence. All right, so we want A sub 1, A sub 2, A sub 3, A sub 4, and A sub 15. All right. So here, if I wanted A sub 1, then I need to plug in 1, right, for my n, and then I can come up with the answer. And so when I plug in here, I've got 1 raised up to the negative 1 raised up to the 1 power, that's negative 1. And then if I put in a 1 here, then that'd be 2, right? And then 2 minus 1 is 1, so negative 1 over 1 is negative 1. Okay? Now, I can keep doing this the hard way, or I can do it the easy way. Why don't we pull up a calculator here? Alright. Our favorite calculator app, Desmos. Pull it right up. And let's plug it in and see what we got. Okay, so here we can just go fraction. We can go negative 1 in parentheses. We can raise it up. We already got the first term, so why don't we go ahead and just put squared in there. Come down to the bottom. 2 and 2. Close it off, minus 1. And so that gives me 0.333. Now, since that's a repeating decimal, we know that that fraction is going to be 1/3. And if you're not sure, you can do 1 divided by 3 in a normal calculator, and it'll show you that it's 0.33. All right, so you've got to be able to convert from decimals to fractions. All right, for the next one, the third term, I'll just go and change those 2 n's to 3's. So I'll change this to a 3, and I'll change this to a 3. So I have negative 0.2, and as a fraction, that would be a negative 1/5. Okay. All right. Let's change it now to 4. 4 goes here. Change that 3 to a 4. All right. Now, this one may not quite be so obvious. As to what the decimal equivalent is, but hopefully by now you're kind of seeing a pattern So this is negative 1 over 1. This is positive 1 over 3, negative 1 over 5. What's happening to the denominator? Going up by 2 every time. And so if you were just to make a guess at what this decimal would be, I would bet that you would say negative 1 over 7. And we can double check that and see if we're correct. 1 over 7. And it is the same decimal. Okay. All right. And so negative, positive, negative, positive. So the odd terms are negative. So A15 should be negative, right? And so now I just kind of want to see if I can take this up now to see what the correct fraction would be. So let's see what it is as a decimal. If I take this and change it to 15 now, and I take this and change it to 15, all right, we get this. So it is negative. We do know that. I just now need to see what fraction this decimal would become. And decimals has a lot of features. Let me see if it has a decimal to fraction calculator in it. I'm not sure that it does. I don't think it does. Yeah, I'm not seeing one. And so what we can do is we can either count it up, right? And so 15, then, 15 times 2 would be 30. And so we could say that's either 1 over negative 29 or 1 over or negative 1 over 31. So those are the two that I would guess. So let's see which one matches. Let's go with 29 first, and I'd say that's the right one. So it's negative 1 over 29. All right. So that was a quicker way for us to come up with it without actually having to count up 15 times, is what I was getting at. Okay? All right, and let's see. Another way you could kind of think about that too is 2 times, let's see. 2 times 2 is 4, minus 1 is 3. 3 times 3 is 6, or excuse me, 3 times 2 is 6, minus 1 is 5. 4 times 2 is 8, minus 1. And then 15 times 2 is 30, minus 1 is 29. So that's another way also you could guess that it was 29. All right? And I'm sure that you could find pretty quickly online a decimal to fraction calculator to where you could just type this in and it would convert it back to a fraction for you. Okay, you could probably find that online pretty quickly somewhere. All right? The next one is actually a recursive formula that they give us, and we want to write the first 5 terms of this sequence. So we need a sub 1, a sub 2, a sub 3, a sub 4, and we want a sub 5. All right. Okay, so that's what we're looking at. Okay, so on this one, okay, they don't give us the explicit formula, they give us the recursive formula. Now, for the recursive formula, they need to give us the starting term, the a sub 1, so this is the first term. Then they need to give us the recursive formula that gives us the term defined in terms of the previous term, which they do. All right? So a sub k is given to us as 2 times a sub k minus 1, which is the previous term. Right? Okay, so here, a sub 1, I don't think anybody should miss the first term because they gave it to us. And it says write the first 5 terms of the sequence. Okay? Let's see. So now, beginning with the second term, so k sub 2, the second term, is going to be 2 times k sub 1, right? A to the k minus 1, which is the previous term, plus 1. Okay, so if I want the second term, then I need to do 2 times the first term plus 1, because a sub k minus 1 is the previous term, which was 3. So if I plug 3 here times 2 is 6, plus 1 makes 7. All right? Then it's the same thing again. I need to plug 7 times 2, 14, plus 1 is 15. All right? 15 times 2 is 30, plus 1 is 31. That's the fourth term. Okay, so always the next term is obtained by taking the previous term. 31 times 2 is 62, plus 1 is 63. All right? And so this one's not a pattern where it's just adding the same number every time. It's a little more complex than that. All right? But anyway, that's how you would use a recursive formula. All right? So if they had asked you, that's why they just asked for the first time. If they had asked me for the 15th term here, we would have had to do a little bit of work, because the recursive formula only allows you to get the next term in line, not the 15th term in line, like the explicit formula does. All right, so now in some of the sections coming up, we will be learning how to come up with the explicit formula given the terms in a sequence. All right, but that's for the sections coming up. So at this point, you're ready for your quiz.